Build a startup out of Tel Aviv. We started this company 5 years ago with the vision of building the next generation radar. Our vision was that a radar is a very underutilized sensor outside of the military, and we wanted to bring to the automotive and the civilian applications the abilities of a military radar by using the same techniques and putting it into chips that will allow this to happen. With our radar, we are allowing zero road fatality reality, and putting the radar, we are allowing zero road fatality reality, and putting the fundamental sensor that will help drive autonomous driving forward. So basically today, there is already some radars in cars. Actually, 20 or 25% of the new cars that sold each year has already a radar inside them. They have also a camera. But the result is those pictures that you see in front of you, a Tesla crashing into a semi-trailer, a Tesla crashing into fire truck, all of those cars are big. It's not something that it's complicated to recognize, but today's sensor fail in recognizing them. Why is that? First of all, the camera has a limited range. A camera cannot see this kind of cars in more than 100 meters. So when you're driving on the highway very fast, you might miss it. Also, the camera is very sensitive to a sun that is shining directly on the sensor, or to a rain or fog. The radar, from the other end, today has a very low resolution, and because it has a very low resolution, the manufacturers are using only Doppler as a signature to a target, which means only moving objects are detected by the radar. And a semi-trailer that is lying down on the road is not moving, so the radar is failing in detecting it. So current radar and camera solution cannot solve the problem because of poor resolution. They cannot detect stationary objects. They don't have the ability to see an elevation, which means a car under the bridge, and the false alarm rate of today's sensor is very high. This is the most advanced radar picture that exists in today's cars. This is the radar that installed in the most advanced Tesla, and as you can see, the radar detects few points, something like 30 points in the scene, and this is the actual scene. So there's no way that the computer of the car or even a human being will be able to understand from those points what the scene is all about. So this is the reason why today's radar are really unusable. This is our 4D imaging radar. 4D stands for a radar that can actually see elevation, detect Doppler, and has a very good range resolution. So when we are driving on the highway in the middle of the night, we can see clearly the cars passing us, and we can see clearly the bridge that we are passing below, and the car below the bridge. Everything here, as well as the sides of the road, are detected by our radar in real time. So the benefits of a 4D imaging radar is, first of all, that it's function in all weather and all lighting conditions. At night, fog, rain, the radar works perfectly on those scenes. Also, the sensor itself, if there is rain on the shelter of the radar, it continues to work like it was before. But if there is some rain on the camera, you suddenly getting into problems of detections. The radar is a real long-range sensor. We can see a car up to 350 meters motorcycle in 250 meters, a child jumping to the road in more than 150 meters. All of those objects are detected by our radar from a long range. Our radar has a very wide field of view. We can see up to 140 degrees, which means we can see everything in front of us in an ultra high resolution. So we can really separate between a car and a motorcycle, a child between two cars. All of those scenarios are detected by our radar. It's a 4D radar, which means, as you saw, we have the elevation. We are able to see the bridge. We have a very good range resolution, so we know how far is the car from us or the child is from us, and we can actually detect the Doppler, so we detect the velocity of the objects. And what is more important than everything is in a mass production, this is a $100 radar. It's a sensor that can get into a regular family car in a price that everyone can afford. And with this radar, we can make all autonomous applications from safety to full autonomous driving. So what 4D imaging radar is really bringing to the market? What it is really doing? So first of all, this is a radar that, as you saw, is generating a picture that is almost good as the camera. It's a point cloud where you can see hundreds of objects, as opposed to today's radar that can barely detect 32 objects in a single frame. With this amount of objects and with a point cloud, we are able to easily fuse it with a camera and get a real-time full picture of the environment in order to take decision. Because it's a high-resolution radar, we can separate easily between motorcycle and truck. We can sense the child stepping into the road. We can localize the car on the lane and understand if the car is outside of the lane because we have a very good resolution. We can see objects above and under the bridge and above and under the lane. And most important, and the main problem and the main reason for today's accident, we can detect stationary objects easily. We can feel them, we can see them, and we can shape them easily. So our first application is an imaging radar chipset for the automotive world. The tier ones are buying from us the chipset and the reference design for the radar, and they are building based on that a full box of a radar. The car manufacturers are integrating our radar into the vehicle sensor suite, fuse it with a camera, and build a full picture of the environment. Based on that, the decision making can work easily. The consumer can enjoy active safety features without even understand what is inside the car. Our technology can serve every level of autonomy. From today's level 2, we are able to enhance dramatically the safety of the car and actually prevent 99% of car accidents by detecting a child jumping to the road, by detecting stationary objects. All of those scenarios, our radar can detect and make sure the car will be able to stop safely and make sure that the driver and the car won't hurt. After the active safety comes what is called level 2 plus, level 2.5, which is a highway autopilot. You can drive without your hands on the wheel on the highway, and traffic jam assistant, which is a very important feature. So on the traffic jam, you can just lie down and make sure the car is doing the job for you. After this kind of a level 2.5, there is level 3, which gives a full autonomous driving on the highway, including coming out of the highway. And full autonomous driving is coming in level 4, and in level 5 there is not even a wheel in the car. So at the past 4 years ago, the industry used to believe that as much as sensors as you bring and as much as sensors as you install on the car, you will get a better solution for autonomous driving. 12 cameras, 10 radars, 6 lidars, V2X, all of it together on the car. But the reality is that those sensors generate a lot of data. And data means processing this data, and means a lot of data. And data means processing this data, and means fusing this data. And this what actually made autonomous driving slowing down, because nobody was able to solve the processing data. All of the robot taxis that are driving today and the Silicon Valley and the other has server farms on their backtrack. And this server farm costs $100,000 or $200,000, which actually makes it unfeasible for a real product. We believe that as much as sensors as you put, you also hurting the battery, because with this amount of sensors and with this the processing that is needed, the battery will die before the car can even exit the parking lot. So our take on this market is, if you put a smarter sensors on the car and not more sensors, you get less processing and you can get to a scale. So 2 or 3 radars like we are building together with 8 cameras can actually solve the problem in affordable price, much lower power, processing power, and power consumption. The technology that is making all this possible is based on our proprietary chipset. We developed 3 chips. Our dedicated radar processor, the first HD radar processor in the market, RF transmitter, and RF receiver. We are the first in the industry to leverage the most advanced silicon process, 22 nanometer, that allows us to reduce dramatically the cost and to increase the performance and reduce the power consumption. Our radar processor is enabling us to process a real crazy amount of data. So a real HD picture of a radar. So a real HD picture of a radar is around 30 giga, which means if you want to run this processing in 30 frames per second, you need to process 1 tera. Our dedicated processors knows to shrink this amount of data, to subsample it, and to produce a full picture out of the subsampled data, and by that solving the problem. All of our core technology is patented, more than 12 patents covering the technology, mainly in the signal processing and our ability to deal with mutual interference with the 200 radars on the same road interfering each other. This is our core patents. We believe that our radar has a lot of potentials also outside of the automotive industry. Consumer electronics and IoT. Imagine a vacuum cleaner that is working fully autonomously at your home and doesn't stuck into things because the radar knows how to sense what is going on around it. A radar that installed outside of the home and can see if a burglar is getting into the home at night. Delivery pods. Those delivery robots started to be operated during the COVID in China as well as in the States. But today they cannot go to mass production because there is a very expensive LiDAR, a laser-based sensor on them. With our sensor, those robots can get into a real scale and be a real solution in the market. Autonomous robots, heavy machinery, transportation, all of those verticals can leverage the technology that we'll develop. A few months ago, we were named Sonicorn, means that we are very close to be a unicorn. We are one of the most promising startups around autonomous vehicle technology, and we believe that the unicorn is on his way to our office. We are 70 people, 6 of them PhDs. We are running majority of the R&D activity from our Tel Aviv office. Sales and product is done in the US, and we have in Beijing also sales and customer support. Our product is in a stage of engineering samples. We are shipping samples, and we are collecting orders for a first batch of mass production a year and a half from now. We raised till now around $55 million we are post-B round, and we are opening our C round very soon. Thank you very much for your time, and hope to meet you face to face in the future.